We are about to start. So good morning, everyone, and thank you for joining us today. My name is Julio Gonzalez. I'm from AgileTech Connect. We specialize in delivering unbreakable internet connectivity, telemetry solution for the mining and industrial sector. My background, I'm a mining engineer working in mining for the past 15 years in Australia, PNG, Chile, and Peru. So in today's session, we explore how cutting-edge technologies are enabling mining operations to stay securely and reliably connected at all the time. Feel free to put your question in the Q&A session. So there is a link at the bottom of the session, so you can start making your question at any time. So let's have a look at the topic we're covering today. So we'll start with a brief introduction of AgileTech Connect, followed by the cause of being disconnected in mining operation. And then we explore the connectivity challenges in mining, the impact of unreliable internet on safety and production, and discover which mining operation use the most data and require the strongest internet connection. From there, we'll discuss some of the leading mining examples, including BHP, Rio Tinto, and others. And we'll introduce the solution for internet connectivity, Peplink, a game changer technology that provides unbreakable internet connectivity in mining operation. We talk about Peplink, and we finish with a live demo of Peplink bonding Starlink and Cellular network in real time. So today we have two guest speakers from end-to-end connectivity. We have Josh Velling, who will explain the advantages of Peplink, and we have Satish Killekar, who will run a live demo showing how multiple internet connections can merge, including Starlink, to provide unbreakable internet connectivity. So let me start by giving you a quick overview of who we are. At AgileTech Connect, our mission is simple, is to keep your operation connected no matter how remote the environment. So we specialize in delivering unbreakable internet connectivity and real-time telemetry solution for the mining and industrial sector. So mining operations face unique challenges. So they are located in remote areas, they have hard conditions, and they are dependent on real-time data. So that's where we come in. So we offer unbreakable internet connectivity, enable high-speed, stable internet anywhere, including in the most remote and on off-grid environments. So we also provide real-time monitoring, ensuring that your system, asset, and operation are always visible and trackable through advanced telemetry. Also, we integrate your technology or our technology into your existing infrastructure for seamless experience. So let's talk about something that every mine wants to avoid, downtime. So because in mining, the cost of being disconnected isn't just inconvenient, it's very expensive, can be dangerous, and it's operational disruptive. So on the right, you see a chart that compares the cost of downtime per hour across several industries. And not surprisingly, mining sits right at the top, reaching up to $500,000 per hour in large operations. So why this number is very high in mining? It's all begin with operational downtime. When internet network fails, autonomous machine may stop, production pause, and working are left waiting. So every minute without connection means loss of time and also loss of money. It's not just about systems, it's about people are left behind. So when the team can connect or receive data, they're essentially left blind. So now let's talk about alerts. Rely on internet connectivity. So if the connection fails, emergency response can be delayed, putting your workers in danger. So when we talk about unreliable internet connectivity, we're not just talking about slow internet, we're talking about loss of production, higher maintenance costs, safety risks, and missed innovation opportunities. So now let's take a closer look why mining operation face serious internet connectivity challenges. First of all, mining sites are located in extremely remote areas, hundreds of kilometers away from major cities. These places offer lack of fiber optic network, a stable 4 or 5G, and basic infrastructure. Second, extreme weather condition plays a huge role. We're talking about environment with heat, heavy dust, torrential rain, and even snow, all of which can degrade and may disrupt traditional networks. So if you see the map, most mining operations are located in very remote areas, so far beyond the reach of traditional 4 and 5G networks. So cities may have a good and reliable mobile coverage, but mining sites often have very weak or even no signal. So the map shows that many remote mining areas may have no connectivity at all. Because of this lack of reliable connectivity, mining operations are forced to rely on more expensive alternatives like a satellite internet, we have high latency and very costly, or they need to build LLT networks. So basically, the customized solution that require upfront investment and ongoing maintenance costs. So now let's take a look at the application in the mining that consume most of the internet connectivity. As operations get more digital, the demand of bandwidth grows, especially with real-time system, automation, and cloud integration. So topping the list, we have any video monitoring or streaming. So whether it's a security cameras, video inspection, or even Teams on Zoom meetings on site, the systems are extremely data intensive. Multiple videos streamed running at the same time can push your network to its limit. So second in the league, we have autonomous and remote control equipment. So autonomous and remote control machines like haul trucks, drills, and loaders that are dependent on real-time data and video feeds. If the network fails, even for a second, the work may stop and critical and safety can be at risk. So there is also a need for a reliable connection and all the time. And also let's talk about telemetry and IoT. So even though this sensor sends a small amount of data, when they have hundreds or even thousands of them, the total data usage grows very fast. So the system needs a steady connection, efficient data handling, and low power network to track things like a fuel level, machine vibration, and gas detection. And lastly, we have mine safety and emergency system, like a gas detector alert network. They don't use much data, but they're extremely important because they need to be connected all the time because any delay on network failure could put lives at risk. As you can see, the demand for the network on site is growing. From bandwidth 100 video feet to always safety system is critical to design a network that is not just fast, but smart, secure, and reliable and all time. So now let's zoom in some of the most advanced mining operations in Australia. These sites are not just global leaders in production, but they're also pioneers in connectivity, automation, and innovation. So the first one is BHP. So BHP have a mine called Olympic Dam, what is the biggest mines in the world. They're producing copper, uranium, gold, and silver. What makes this mining operation unique is the advanced technology using IoT, automation, and digital twins to manage all the different operations. This requires constant data transmission, real-time monitoring, and a strong connection network. On the other hand, we have Rio Tinto, or the Pilbara operation represents the world's largest automated mining network with fleet of automation, haul truck and train. So the entire operation is managed from a remote operation center in Perth, over 1,000 kilometers away. So the level of automation demands ultra reliable connectivity capable of supporting remote data streaming 24/7. And we also have Newmont. Newmont has been on the news because it has been the first operation to deploy a private 5G. So this high-speed network support edge computing and deliver advanced automation while enhancing work safety. This is a prime example how 5G is becoming a fundamental layer in the next generation. So these mines are leading in the trends of mining using autonomous operation to drive industry forward. As mine become more advanced, the demand of fast, reliable internet will only continue to grow. So now that we have covered all the challenges of mining connectivity, let's talk about the solution. So mining uses different networks like cellular, satellite, or fiber, but keeping them stable and reliable is the challenge. So that's where Peplink technology comes in. So Peplink combines multiple internet sources to create a strong, unbreakable connection even in the most remote location. So to explain this in more details, I'd like to introduce Josh Velling from End-to-End Connectivity. He's an expert in Peplink connectivity solution. Josh has worked on setting up a strong and reliable network in mining, industrial, and business environment. And today he'll show us how Peplink bonding technology keep operation online, efficient, and always connected. So please, Josh.
G'day, everybody. Hopefully you can see my screen I'm sharing. All good?
Not yet.
Not yet. I just, that is not a good thing. I just pressed the share button and it has, do apologize for that. Let me try that again. Share.
Yep.
We're up and running. Beautiful. Sorry about that. Good morning, everybody. My name's Joshua Velling. I look after Peplink for Australia and New Zealand. We're the master representatives of the brand. And I like to tell people when they ask me, what does Peplink do? And I say, Peplink provides the best internet connectivity for any point on the planet. Let me say that again. Peplink provides the best internet connectivity for any point on the planet, be it in a fixed location, be it on a vehicle, in a vessel, in a helicopter, an airplane, doesn't matter where. And as Julio has indicated, we can make such an outrageous claim like that because what we're doing actually is not that complicated from a concept point of view. And that is, we take all the available WAN connections that can be delivered to a single point, the router, and we bond them all together to make a stronger, more reliable internet connection. And you can see in the backdrop of on our displays today, multiple Starlinks. So we can take, for instance, multiple Starlinks together and create a bigger, more reliable internet connection. And Julio has done a great job explaining some of the work-specific applications of what Peplink can deliver in a mining environment. However, there's one thing too I want to highlight, and that is Peplink, by delivering better internet, can make the lives of the workers in the mines even better. Because what Peplink can do is connect and provide real-time applications like FaceTime and communications for all the workers who can still be in touch with their home life, even though they're remotely out. And a few years ago, you couldn't do that, or it was extremely expensive. But today, through the power of modern day communications and reliable comms, we can now deliver these types of services. So today, I'm going to just very quickly give you an overview of Peplink. This is very simple, it's non-technical, so bear with me as I go on this journey. But Peplink doesn't matter what your WAN connections are, right? It doesn't have to be multiple Starlinks. It can be Starlink and 5G, it can be Wi-Fi as WAN, or it can be a fixed connection in any combination. There's no limit. We can bring them all together to provide that best internet connectivity. And whilst today we're talking specifically about mining, but Peplink is solving problems for customers in multiple industries today. And the solution works as a combination of hardware on site, and we have a head end that brings it all together. So you bond between two entities. There's a management tool that makes it really easy to control. And then there's the bonding magic, which we call SpeedFusion. And let me explain what it actually does. So SpeedFusion literally takes all the available WAN links and breaks the internet down into or the communication into an individual packets And it sends packet A down WAN link A, packet B down WAN link B, packet C down WAN link C, and so forth. And then at the other end, at the head end, it reassembles that data. And that data then can travel faster, more reliable. Even when the individual net in WAN links are best effort, then they might be up and down. Starlink is in a burst mode, or Cellular has problems. Doesn't matter. Doesn't matter how poor the internet connections are. Peplink can get the best out of what you can deliver to that point. And then they've just enhanced that performance by they dynamically looking at the strengths and weaknesses of each WAN connection and then optimizing the number of individual packets that it sends down each of those WAN links to give you an even better internet connection. And in some cases, speed may not be important. Maybe what's important is just the baseline reliable connectivity over best effort networks. And in that scenario, we've created this smoothing function. And literally what it's doing is it's taking one packet and sending it simultaneously down all the available WAN links, and then grabs the first packet that turns up and discards the rest. But what that can do is create a jitter-free, stable internet connection over multiple best effort networks. And last but not least, we can do live and hot failover without a session drop. So even if the one link goes down and it's still going, the end users have no idea that there's been a break in the connection. So that's the concept at a high level of what Peplink can do. In addition to this bonding technology, Peplink is the first partner with Starlink, a technology partner. And what they have done is a whole range of incredible integration and improved performance over the Starlink connection. At this stage, I'll just ask you to take my word for it, because I'll let Satish actually show you in real life just what that can do. Peplink, very simply, it creates a connection between the endpoint and the head end, and once that's done, that's all the black magic, so to speak, or the magic that occurs. And then once that's established, you can then enable these bonding capabilities. And just for the technical people amongst you, Peplink will behave just like any other router that you may be dealing with, as well as doing the SpeedFusion technology. So without any further ado, I'm going to hand over to Satish, and he's going to show you live just what we're talking about. Over to you, mate.
Thank you, Josh. Good day, everyone. Let me share my screen and start with it. Let me know if you're able to see my screen. I think
we can see it now, Satish.
Yeah, okay. Yeah, thanks, Julio. So what you see on my screen is the InControl 2, Peplink's device management platform. And this is what you'll be using for managing all the Peplink devices within your network. And this particular, I'm not going into details of how the whole platform design is, but I'll focus on the device at hand, the dashboard. There's a lot more things you can do. You can configure multiple accounts, you can configure multiple groups and all of those things within the Peplink. But I'm going to talk more specific on the device level today. And this is one particular device which is called HD4MBX, is 4 built-in 5G into it. So you've got 4 5G modem. Each of them accepts 2 SIM cards for redundancy, but one remains active. So total 4 modules, 4 active SIM cards. It also has WAN options where you can connect Starlink, OneWeb, GSAT, NBN satellite, whatever is available on the site, and you can connect that and it will receive that connection as well. What you see on my left-hand side, right-hand side, you see there is VLANs, which is the local network configured on the device, and we then have the WAN connections. So these WAN connections, particularly, you can see there's a SpaceX logo against the 3 WAN connections. So we've got 2 standard residential Starlinks and 1 high-performance Starlink there connected. And as Josh mentioned earlier, what Peplink has done with being the first technology partner with Starlink is it gives you a level of information that no other vendor today provides. So that gives you a section of information which is particularly catered towards Starlink. And what you see here is alerts on that Starlink. These are live information from the Starlink terminal on the standard that we connected on WAN 1. It gives you alerts. So these alerts are specific to Starlink antenna or the panel alert. So it could be a patch update sent by SpaceX team, or it could be showing any alerts as to obstruction, or if there is any if there is an environmental condition that the device might be overheating. All of those alerts you will see here, or if there is a new security update going on it. It gives the ID of the panel as well, gets the revision, hardware revision, and the software version that's on that panel. It gives you the uptime of the panel. So this particular has been up for 7 hours, 14 minutes. And there is a small subsection within that which says boot count 198. So this particular, nothing to be concerned about. Every time a Starlink terminal reboots, this counter goes up. So we have had this terminal for about 3 years, and it has rebooted around close to 200 times. It gives you a fraction obstruction on that panel as well. So our panels are located in our office in Kensington, where we have a very small 1 square meter real estate that we have placed 3 panels. Not ideal to place them. You're supposed to place the panels at least 0.5 to 1 meters apart from each other, so that you have that the wavelength range that's covering that panel, and you're not obstructing it. So this obstruction is particularly that if there's any obstruction over the panel, it notifies that and how long that's been obstructed for. It also gives you uplink, downlink, and latency of that particular link. So right now we are just running a purely simple health data on it, and that's why it's a few kilobytes on it. If you're running your data continuously, this is our demo equipment. If you're running your data continuously, it'll show you what rate that each of the panel is sending the data. It gives you the angle also, at which the Starlink is connected. The best thing about this is you could also reboot and stow the Starlink. So in case you had some issues with the Starlink, one of the panel connected to the device, you could send a reboot signal and that will reboot the Starlink. Or if you want to store them during non-operational hours, you can store them as well. And similarly, irrespective of how many Starlinks you connect to a Peplink device, this particular device can support up to 3. But if we have a range of hardware that can support all the way up to 15, 20 Starlinks, and the maximum that has been tested with Peplink is 21 Starlinks. The largest deployment in Australia is 8 Starlinks, and Starlink generally recommends not to go beyond 12 Starlinks. That's, again, this goes back a couple of years ago, which they put 16 Starlinks on a Peplink, and that nearly broke the Starlink's backbone internet connection for some time. And that's where Starlink, that partnership with Peplink, that helps. And that's how Starlink came about and said, at a particular concentrated location, you're not supposed to put more than 12 Starlinks. Probably that might have changed over a period of the last 2 years. But it gives you the indication of how many Starlinks really can you bond and achieve a high throughput as well. Similarly, if you have your own private 5G on a particular mine site or your own industrial site, you could combine the 5G connections with multiple 5G modules within the device and achieve a higher result. And if you have a public 5G network connection, i.e. Telstra, Optus, or other carrier available at the site, you could also use that connection to include into this for bonding. So what you see with the cellular as well, it gives you a lot of level to troubleshoot information. It gives you the IP address and subnet mask, which physical SIM slot is in use. You could also push an eSIM from the platform directly onto the device if you have your own eSIMs. It'll give you the information about which network it's connected to, what type of network it's connected to. So this one is connected to 5G NSA, and you can see all the frequency bands it's currently latched onto and the respective signal strength, signal quality, noise. This is very handy for someone doing IT and looking at a mine site which is remotely located to troubleshoot the device and find out what could be causing the speed or throughput or dropout issues. And below that is the SpeedFusion VPN. So as Josh mentioned, it's a 2-part solution. You have the head-end equipment and you have the edge. The edge sits on the customer sites or the mine site, and the head-end sits in the headquarters or data center or a cloud. And between these 2 devices, you bond the connections to achieve a higher throughput. So let me take you to the device itself and show you what that bonding looks like. So these are the 3 Starlinks. I am bonding this. We are based out of Melbourne, and I'm bonding these connections, 3 Starlinks plus 4 cellulars, to our own headend hosted in AWS Sydney. And if I run a quick download test, you will see that per WAN connection, I get certain download speed. And at the bottom, that's the aggregate I'm able to achieve with a combination of 7 WAN connections. So overall, I'm able to achieve close to 500 and 500 plus. This particular device is rated for 500 to 600 meg throughput. So that's where it's you can see the maximum throughput kind of throttle at. It doesn't mean that it will not go beyond that. It can go beyond that, but there's bigger hardwares that can do up to 4 gigabits, and the new hardware that's going to be released in a month's time can do up to 30 gigabits. So you could have more Starlinks connected to it, plus say 12 Starlinks, 12 OneWebs, and you can just create wonders in terms of what speed you can achieve there. While in operation, if I lose certain WAN links, it doesn't mean that I lose connectivity. I will reduce the bandwidth, however, because I've lost WAN connections, but it will seamlessly send data without disruptions, without packet drops, without session drops. So when the WAN links come back online, it will start participating in the bonding, and you'll see that the bandwidth naturally goes up, and it will give you a higher capacity link. This is a symmetrical link between the two sides, which is the head end and the edge, and you can also track the packet loss of each link and the latency of each links. And similarly, if I have to run a quick upload test, you will see that per WAN connection, I get certain upload, and at the bottom, we get the aggregate upload speed. So with the uploads at Starlinks, it again is very limited. So you get a maximum Starlink rates is you will get about 25 meg upload. Typically averages around 10 to 15 meg per panel. So with that, at least you're still getting a significant amount of upload in cases where you're getting nothing. Combining just the Starlinks, you can still see that you're able to achieve significant upload throughput, even with the with with 3 Starlinks, whereas if you had to take a fiber and connect it, it's limited to that physical connection. So that's bonding for you. There are other features as well within Peplink. So in case you have, this is more useful for people doing the IT and managing the systems. Peplink also has a feature called InTouch. This is out-of-band management of your LAN clients on the side. So if you have a connection to that device, you could also connect to devices sitting behind a Peplink remotely from the platform itself to achieve, more another way of getting into your systems and troubleshooting them and identifying. So we've got here a TP-Link switch. It doesn't have to be Peplink. It can be anything else. There are a range of equipment that sits behind. They might be cameras, printers. They might be PCs sitting. You could remote into those devices and troubleshoot or fix some issues that might be reported to you. So that's the bonding. If you have any questions, pop them onto the chat and we'll be happy to answer.
Thank you very much, Satish. So just to highlight what we have done, again, with the visual that you have in the background, this is 8 high-performance Starlinks, 500 kilometers north of Adelaide in the middle of nowhere, providing amazing connectivity. What sort of throughput are the guys seeing there now, Satish?
Yeah, so the background that you see on our each of the panelists, these are the 8 Starlinks that we have connected in the mine site, and we were able to see TCP throughput of about 1.3 gig down and about 250 to 300 meg up, and this was for the mining camp to give connectivity for the miners to connect back to their home, their loved ones, and have entertainment on site.
And it also, ironically, provided a failover for the corporate data as well, because they had a problem with that, and it actually it just worked. So it truly is an incredible piece of technology. Julio, I'm going to hand back to you. Open it up for you and for people to ask questions.
Very good. Yeah, so just a reflection, talking with the different miners, there is always a question about security, say cybersecurity. So Satish, how Peplink is managing cybersecurity for the operations?
Yeah, so Peplink is not just merely the router that is doing bonding. It also has a firewall in it. It's a stateful firewall, and it gives you application control, quality of service, content filtering, all of these nature. But if you are looking for placing an appliance or you want to tap into Umbrella DNS or Zscaler, the likes of these SaaSes that give you internet-bound security, you could also run a VPN and route all the traffic from Peplink into um, that SaaS platform and achieve that security level as well. But more typically, what we see is we have the edge site send all the data into the headquarters, and headquarters is where you'll firewall everything. So that way, you're limiting the number of firewalls you deploy at each site. You have a Peplink that transfers all the data into the headquarters, and you're firewalling. Say, if you want a layer 7 firewall, which is typical of certain requirements in terms of deployments. Peplink doesn't do layer 7 for firewalling. It does stateful firewall. So if you require a layer 7 firewall, you could run the Peplink head-end equipment behind a layer 7 firewall and run that security over it. So Peplink does provide around 99% of security. It'll meet 99% of your security needs, but in cases where the requirement is for the layer 7 firewall, you want to check the payload, you want to check the headers, you want to check everything within that packet, then we recommend going with a third-party firewall because that's a hard requirement for you. And with that, you can plug them systems into the firewall, and you will have that level of security achieved.
Yeah, that's a really good point, Satish. And let me just hone in on that. The Peplink can stand alone in its own right and has its own SD-WAN functionality. But more importantly, we see customers deploying the Peplink into existing infrastructure where that infrastructure has, it's all under one big management platform, but there's segments where there's poor connectivity. So you can configure the Peplink into a sort of like a pass-through or a drop-in type of mode and get the bonding capability, but retain all of your existing networking infrastructure, security, and what have you. And it just then presents as an additional WAN connection. And so we see that type of deployment very, very common. There was a question, I think, around how does the Peplink stand up in rugged and tough environments? Can it really handle the Australian environment?
Yeah, so with the Peplink have a range of hardware that are data center specific, and that requires temperature controlled environment. Peplink has also hardware that is designed for rugged environments. So the likes of mined vehicles where you have high vibration, you have high temperature variance, plus also these mine sites could be sitting anywhere across Australia, and the temperature, the terrain, the different topologies across Australia can cause different environmental conditions, and we do have hardware that supports that are IP67 rated that could be mounted on top of the roof. We have hardware that is ruggedized and dust proof that can sit inside a vehicle. We have M2L connector hardwares as well. That is that is a key requirement where you have high vibration, such as these high the loaders and the dumpers that we have in the mining sites. So we have a range of equipment that is designed for various environments, and together, irrespective of what variant it is, they can run what you saw on my screen today, which is the bonding and the smoothing and the high capacity. So you could achieve a greater resiliency of network throughout your mining site, not just for the point in the mining site, but also the vehicles and the other equipment sitting on the mining site. You can connect them all together and bring about as one single network.
So does Peplink, is it the complete solution, Satish, or can it work with other technologies as well, like mesh and things like that? How do we get into all those hard to reach locations?
Yeah, so Peplink, if it is a new install, it is a complete technology, but we have cases where the customer already has an infrastructure and we are just plugging in the Peplink to enable them for the extensions that they were not able to connect previously. So looking at a fresh install, it does have Wi-Fi mesh enabled on the devices itself. And you could extend your Wi-Fi coverage through the LAN side of the things, where you can extend the Wi-Fi with Wi-Fi mesh across multiple access points. Peplink has outdoor IP67 rated access points as well, and switches, the rugged switches that are designed for harsher environments. And you can connect all of these systems with a range of Wi-Fi. You could also plug in a third-party mesh technology within the Peplink that can extend those are typically your proprietary, spectrum, where you license the spectrum on Wi-Fi, and you have those Wi-Fi mesh devices can extend the range up to 50, 100 kilometers as well. you can plug them into the Peplink and achieve that results as well. And for the hybrid setup where the customer already has the infrastructure, say the big four brands, and they are already installed all of them, but on satellite sites where they have poor connectivity or absolutely unable to get any connections on, they could then rely on Starlink, the OneWeb, the GSAT, and bring the Peplink solution into equation and plug into their existing infrastructure, either in the drop-in mode or pass-through mode, and enable that connectivity and get that higher capacity for that sites, which they could not do earlier.
What about situations where customers are using like private LTE or private 5G? How does Peplink behave in that environment?
Yeah, so Peplink, today's Peplink has the latest 5G chipset, although Peplink's 5G chipsets from the beginning, which supported NSA, the latest 5G chipset is based out of 865, and that does you carrier aggregation on 5G. The NSA 5G chipsets do a single frequency, and they can latch onto a single 5G frequency itself. So coming to the private side of things, so carrier aggregation is one of the key factors of cellular, high-end cellular infrastructure, which is Cat 6 and above and 5G and above. So all of these modules or the 5G connections that you get on Peplink can tap onto your private cellular 4G or 5G network. The private cellular 4G, 5G network gives you less than 10 milliseconds latency because it's localized to that particular environment. And you could connect multiple devices and that enjoy the benefits of carrier aggregation if you have more than one frequency on the private 5G or private 4G. Typically it is 1800 megahertz, but sometimes it's 18 plus 2100 megahertz. So you can combine those two frequencies to get a higher throughput on those and connect all the sites together, including your equipments.
We also hear there's a lot of stuff going on in the market around edge computing and doing processing at the edge, AI, and all those wonderful terms. What's Peplink's view on that?
Yeah, Peplink, as I said, there are segments which is data center centric, and then there is mobility centric, which you go deploy on vehicles and rugged environments. So each of these equipment have Docker capabilities. Most of the Peplink equipments within the mobility segment has Docker capabilities, except for the really low end of the Peplink systems. And Docker is a very open source term. You could deploy your own Dockers. Peplink reserves half of its resources for Docker engine, and you could deploy anywhere between 2 to 5 Dockers per device. It could be running your duress system in the vehicle. It could be tracking all the information. It could be running your comms system, which is your radio and other things. You could have images wrapped into this Docker and run off of the Peplink hardware, wherein previously you would require a router, a duress system box, industrial computer to manage everything else. So you're kind of consolidating all of these, I wouldn't say the duress, but the industrial computer into the router. And you're now giving the programming interface, you're now giving the application interface, and you're now giving, you can run your own script and code on that to manage different operations across, especially in the vehicle environment where you have too many equipments to track the health and, OHS of the person working there, site engineers and all of that. So it gives you can create a Wi-Fi bubble around the vehicle if you want connectivity for if someone, particularly a field engineer, a site engineer who's visiting the site, wants to go across to a certain length and check the equipments, and he can still be connected to his vehicle while he's away on his tablet.
Thanks, Satish. Again, inviting anybody on the audience to ask a question. Hand back to Julio.
Fantastic. Yeah, just a reflection. We are very focused on the mining operation. However, visiting different mine sites in Australia, New South Wales, Queensland, and even in PNG, there's always lack of challenges in the internet connectivity. It's not only for the mine operation, it's for the whole community, for the people, the business that in the region. That's very hard to do business. And even for when you stay there, you need to stay in a mining camp. And then sometimes it's very challenging to get any connection to do anything. So these solutions, they're very versatile. They're not only for the mining operation, but can be applied for different business environment, right, Satish?
Yes, yeah. So it can be applied in various environments, not purely mining centric, as we saw in one of the slides with Josh. We have multiple verticals that we work on, and yeah, Peplink has a solution for each of those verticals.
Fantastic. We have seen a very good, exceptional reception from emergency services because those services need to be connected to internet all the time. So that's one thing. But in mining, they're also looking to back up all the mining emergency services. So I'm talking to one of the mining sites here in Australia, and what they have is they have several sources for internet. So they have 4G, they have Starlink that seems to be very popular as a backup. However, they have like that working in parallel. So what Peplink bring is basically to merge all together, right, Satish?
Yeah, that's correct. So you could have any number of connections, but it could be Wi-Fi as WAN, it could be cellular, it could be cellular 4G, 5G, it could be Starlink or OneWeb or any other means of connectivity that gets you that WAN bearer. So you can combine them all together, as you said, merge, combine them all together and achieve that seamless failover without the packet drops and higher capacity of that link. So you could benefit from having those many links and achieving the capacity with those links.
Very good, very good. So, thank you, George. Thank you, Satish. This is the end of our main session. So now we would like to hear from you. If you have any question, our contact details are on display. So we are here to support you with anything related to connectivity, Peplink technology, or mining network. So feel free to reach out so we can provide you a very customized solution for your challenges, and we can set up easily a meeting with any of you that would like to continue the conversation. So thanks again, and we are looking forward to stay connected and supporting your operation. Have a great day today.
Thank you.
Thank you.